set the system up for PNM, what it looks like, what importing the modem file looks like, and all of the things that go along with that, making sure we've got the system itself configured to function for PNM, and then from there we've got a couple of really good examples that are including plant maps that will show how, from our experience being out in the field, and even earlier this week when I was out in Phoenix doing some field work with this thing, the explanation of the common point in the system is a challenge to get people to understand, and we'll touch on that a little bit using some actual plant maps that we have that explain what the common point is and how we get our distance to measurement or distance to fault from there. So it looks like we got a pretty good crowd of people on here so far. So I'm going to go ahead and I'm going to share my screen, and you're going to see a wacky little thing that looks like you're looking into an infinity mirror at first until we get started, because we have a new recording tool that I'm using for the first time that actually records everything in MP4, so it can be basically dumped straight up to YouTube and made live. So we'll be recording for this, and it'll be available to everybody that can attend, and I'll send out the link once I get this thing put up on a YouTube channel. So let me get the share started here, and again, you're going to see this crazy looking thing to start with, and I'll get it shut down.
I'm looking at a crazy looking thing right now, Eric.
I know, Sid, but stop looking in the mirror. That's good. So can everybody see my screen? PNM discussion, first page of a PowerPoint slide type thing?
Yeah, got it, Eric.
All right, good deal. Good deal. I still see my things flashing down here. What's going on? Okay, good. Everybody's there. Good deal. So the first thing we're going to talk about is getting the PathTrak system set up so that it's ready to run the PNM application. And there are a couple of things that you have to do in order to make the whole thing work. First of all is Snmp Communication. You have to have Snmp read-only communication to the cable modems and to the CMTSs. Now, if you're going to do some of the other features, upstream spectrum at the CMTS and downstream spectrum from the modems, then you're going to need the community string for write access as well. But since this is a PNM discussion, the only thing that's needed is the read-only Snmp community string. And we'll talk about setting that up as well. The other thing that you need in order to make this whole thing work is the PNM system has to know where the cable modems are located. And there's a couple of ways that you can make this happen. The easiest way is if the server has access to the internet, you simply dump the billing system information containing the street address of where the modem is, the MAC address, and the node name, and we've got examples, and we'll go through this whole thing. You dump that into the system, and the system automatically geocodes it with Google. Or, as we learned in Phoenix this past week, if the server is behind 19 firewalls and has no access to the internet, if the file that you provide, the CSV file, if it contains the latitude and longitude coordinates of where that cable modem is located, then when the remote client accesses it, it will still be able to pinpoint where that modem is. So you have a couple of ways to do that. So let's talk about that. Let's start there from the get-go. I'm going to open up a remote desktop session to my PathTrak server that we have here in the head-end. Can everybody see that? See the big head-in remote desktop session that I just opened up? I'm making sure that everything's still working with this recording that we got going on. I'll take that as yes. This is just a normal PathTrak server. It does have a early version of 4.5 on it, but there's enough similarity of what we're going to be looking at that it's not a big deal. So if I go onto the C drive of this machine and I go into the program files directory, go down to Viavi Solutions, starting with version 4.4, we changed from the old JDSU directory. Everything is now in the Viavi Solutions directory. Trust me, it took me 5 minutes to find it one time. I couldn't figure out why nothing was in JDSU anymore. But we actually updated our directory, and now we install things in Viavi Solutions. We've got what will be the latest version of PathTrak will be there. In this case, we've got an early, let's say an early 4.5. Beneath that subdirectory, we've got a couple of directories that we're going to be interested in. The first is inbox modem. Well, first we'll go to config. In the config directory are a number of XML files that determine a lot about how the system works. Many of you have experimented with the PathTrak server properties when you're changing IP addresses or you're changing port numbers for access, etc. But there's an XML file right here called modem-csv-parser-format. If I open this up in a text editor and we take a look at what's in here, and I know this may be hard to see, but hopefully everybody can read it. So I just can't get that font any bigger. This is the configuration file for the CSV import, modem import file if you do it on a regular basis, say weekly or nightly. You have to do it, the file has to be consistently formatted if the system's going to import it properly. And this is the way that we do it by default. We have 9 columns here, 9 or 10 columns here, and you simply tell this file how you configure your CSV file. Does it have a header? If it has a header, true. If it does not have a header, it's false. In other words, do the columns in the CSV say MAC address, street address, node name, latitude, longitude? Do the columns say that at the top? If so, true. If not, false. If it's CSV, typically it's comma separated, so that's what we're looking at. By default, we assume that the cable modem MAC is in column 1, the node name is in column 2, the first part of the street address is in column 3, we leave column 4, we leave the address line 2. For example, if this was 123 Maple Street, apartment 6, you could actually put apartment 6 in your CSV file and include that as a column. But by default, we ignore that field. The city location, column 4, state, column 5, postal code 6, and then you have your latitude and longitude. Right now, we don't know where they're going to be. So if the customer is going to regularly dump their CSV file into the system, then they need to make sure that this file is formatted to match the CSV file that they're using. And the final thing you see at the bottom is CPE. So if you're doing the cross-reference from the cable modem MAC address to the CPE MAC address, the CSV file needs to know where you're going to put that CPE index as well. And I have a CSV file that I was sent from the ComHim guys in Sweden that's actually quite good. So if I look at it, comparatively speaking, I have a header, cable modem MAC, node name, street address, my cable modem MAC, my node name, the street address, the city is in column 4, the state, if it's important, is in column 5, postal code, column 6. The country really doesn't matter for geocoding, but they have that in column 7. And then they have latitude in column 8 and latitude in column 9. Now, I have a feeling that they're planning to add the CPE MAC in column 10 at some point in time. So if I was going to configure this XML file for this type of a CSV file every time, then true, I have a header, cable modem MAC, column 1, node name, column 2, street address, column 3, city is in column 4. I have no second line address. The state is in column 5, postal code column 6. Then I have latitude, so I would change this to 8, change this to 9, and eventually when the CPE address got there, I changed that to 10. So now when I save that, every time I automatically place this file in the system, again, whether it's nightly or whether it's weekly, however frequently the customer wants to update their information, it's going to look and match up exactly to the format of their CSV file. So does that make sense to everybody from an automated standpoint? Now, if we go back one level, I'll go back to the file structure. Oh, wrong machine. Sorry. Too many remote desktop sessions going. I'll minimize this and minimize this.
So, Eric,
yes.
you want a quick question. The CP MAC, we just need it if we like to use it in PathTrak. That's it.
Correct. The CPE MAC has no bearing at all on PNM, but it makes those question marks go away in the CPE column or in the CM column in the PathTrak Analyzer. It allows you to see in the PathTrak Analyzer in the new version both the CPE MAC, which we've always been able to see, and then it will show you the cable modem MAC in there as well instead of question marks, which is what it shows you now if you don't have that cross-reference. And just to touch on that as a side point, if you're not using PNM, if the customer is not using PNM, but they want to have cable modem to CPE cross-reference information in PathTrak, you would only need column 1 and another column with the CPE MAC in your file. That would be all that you would need, and then you could import that directly every night, and you would have cable modem and CPE MAC addresses show up in the PathTrak Analyzer.
All right, thanks. And the node name to match with the node name of the PathTrak?
That depends on the customer's configuration. We had an interesting thing again in Phoenix this week while we were doing some field trials, where the customer did not trust the billing system information from the fiber node standpoint, and they had named their PathTrak nodes a little bit differently. So he used the actual fiber node information from the CMTS, and they could tell. So his node name would say fiber node 14, and they knew that fiber node 14 equaled node 12 in whatever town we were working in. They were able to determine that. So in a perfect world, the fiber node name matches how they have it listed in the billing system, and that matches how they've named their RPM ports. And that perfect world hasn't been found very many places yet. Some of the places are pretty close, but it still is quite different. We'll have another session at some point in time that talks about how if there's a pattern, if the customer uses a pattern to their fiber node naming to convert to their RPM port naming, there is a way within PathTrak to establish that pattern to say fiber node 123 equals RPM port XYZ. And you can build that relationship so that the system understands it. And we don't have enough time in this session to get to that. So we'll make that another session at another time. So back to the file manager and back into 4.5. There's a folder here called inbox modem. Once the customer has configured this XML file so that it always matches his CSV format, where does he put the CSV file every night or every week? That goes into this folder. So the CSV file gets placed into here. Every night at midnight, the system comes in and looks into this folder and says, oh, I have a new CSV file. Let me import that into my database and let me add or remove any changes in modem information from what I currently have in the database. It does not rewrite the database. It only adds the changes. It only appends it with whatever changes have taken place from the last time it did an import. So if you add 20 or 30 new modems to the CSV file during a day from installations, and those get put into the new CSV file, when the system imports it automatically, it doesn't rewrite 6 million modems. It just adds 20 new ones. So that's the way the automatic import works. But you don't have to do the import automatically. I wanted to start with that because we do have some people that are doing the automatic import, and it works very well. These guys that we were working with in Phoenix, that's how they do it. They have their CSV and they import it automatically, and it's working very well for them. They have latitude and longitude on there, and we know exactly where their modems are. So that part works very, very well.
Quick question, if you don't mind, Eric. So if it was a firewall, you said that you have to place this in there, or can it be FTP'd in there if it wasn't firewall? Can somebody go on mute, please?
Yeah, let me mute everybody. Somebody's not muted. Somebody is not muted. There. Muted.
So is that FTP'd over if it's not a firewall, but if it is a firewall, you have to dump it in there physically?
Well, it depends on your network. I mean, he in this case, this guy had access because the file's coming from an internal source. So it wasn't coming from an external source. So anything that was on network was still behind the same firewall. So it was just a straight over file transfer, a script that he had written that said, go get this information from the CMTS and from the billing system and create the CSV file in this format and then copy it into this directory. So he had written a script that did that, but because it was all internal behind his firewall, he didn't have any connectivity problems when he did it.
If somebody wanted to do that, they'd have to write the script, or we just put it in FTP and FTP it over.
Right, or move it over manually on a thumb drive.
Right. Okay.
Somehow, some way to get it over there. Yeah. If the IT person is clever enough, then they write the script and it gets transferred automatically from that way.
All right. Thank you.
Could we do also a pull from the server, or have a script on the PNM server to do a pull?
Sure. However, if that's how they want to do it, that's fine. I mean, if they have got the ability to pull that information in that format, however they get it in there doesn't matter. We don't specify that, and we haven't written the script because we don't know. They're not going to give us access to the billing system to go get it. So if they want to write their own script or if they write a script in the billing system that dumps the file in there, or if they write some sort of a script on the PNM server that goes and talks to the billing system and has their usernames and passwords and pulls the file in there. Whatever, either way works fine.
Okay.
So that's the automated method of getting the modems and the location into the PNM system, which of course is critical to the successful usage of the system. Is having those modems in the right place is key to being able to get to the point where you're solving problems with that. But you don't.
How often do you read the file, Eric?
I'm sorry?
How often is reading the file? Is it automatically when you detect a new file in it, or?
Well, I mean, anytime there's a CSV file in here, it doesn't. I mean,
Midnight,
it's
right?
going to. I'm assuming that it will be the same file name and it just gets overwritten, and if it's there every night, then it looks at it and imports it, and then it's gone. And so if you have multiple CSV files in there, then it'll probably look at the date and use the newest one. But most of the people use the same name and just overwrite the existing file, and so it's only looking at one file at that time. I'll have to put a couple of different files in here and see what it does when you do it automatically. But in the world of doing trials, as most of us are involved in doing a lot of trials, they don't have the we don't want to go through the time of actually setting up the automatic import of the cable modems. We just want to do it one time so we can get the trial started. So if I go to my PathTrak system, and you're going to see a couple of things here with 4.5 that at least one thing I think that you'll probably be pretty happy with 4.5. And if I want to go to the PNM system, if I go to the features and I go to PNM pre-equalization analyzer, we all know that with 4.4, you're going to have to re-log in order to get into PNM, right? And I'm sure everybody just loves the fact that you have to re-log in order to get there. Well, in 4.5, you don't have to do that anymore. It's all one big happy application that uses the same credentials. So I can go straight in to PNM from PathTrak using that menu. So there's one 4.5 feature you get to see it in advance of everybody else for being on the call. So now that I'm in the pre-EQ tool, the first thing we have to do, and this is a lot of people forget about this step, is you have to tell it what the CMTSs are that we're going to talk to. And there's a couple of reasons that we need to talk to the CMTS. We need to know the upstream channel information that we're using, and we need to know which modems are on what CMTS. And the easy way is to get that from the CMTS. So very simple process. Configure, manage CMTS, add the CMTS. You can either put the host name or the IP address. You put the Snmp read-only. If you're doing upstream spectrum, the write-only. And then it goes and it will, at that time, it will get all of the other information. It'll pull in the system name, and it will pull in the description of the CMTS and the firmware version and all of the other info about that. Tells you what DOCSIS version it is, tells you how many upstream interfaces, and tells you how many modems are currently connected. And this information, and this was one of the interesting things that we noticed when we were working with Liberty Global, is Liberty Global was trying to put a device between the PathTrak PNM server and the CMTS where we were not polling, we were not communicating with the CMTS directly, we were communicating with their device that was communicating with the CMTS, and it was way too slow. It was way, way, way too slow. When you add a CMTS and you hit this done button and you hit sync with CMTS, this information should populate in about 5 seconds. Even if there's 14, 15, 20,000 cable modems on this one CMTS, this information populates in about 5 seconds. If it takes longer, then you've probably got some sort of a communications issue with the CMTS. And another thing that we'll talk about is Murugapan has written and improved a little Java application that kind of helps with troubleshooting communication issues. And on the next call that we do in a couple of weeks, we'll go over that. We'll go over the how to troubleshoot communication issues, because that tends to be the next biggest issue is once you get that information. So we've got our CMTSs added. Everything's good there. We're done. So now we still need to do some navigation things. We're going to go back here, and I'm going to go to the help menu, and I'm going to go to this page, the sitemap page, the help page. And we're going to do a manual import of the cable modem file. So this is what we're looking at. PathTrak modem upload API is where we want to look. So if I launch that guy, this is what we see. And this is the key part right here. Actually, by default, this should probably be unhidden so that you can see it. And if you notice the information here, it matches up to that CSV file exactly. So this is for one-time configuration, one-time import of the modem and address CSV file. So again, if we want to use the file that the ComHim guys sent me, and they sent this to me so that I could look at it and make sure that it was okay. So I have to make this match the information in the CSV file. So do I have a header? I have a header in there. It's true. It's a comma-separated file. Modem MAC, line 1. Node name is in column 2. Address is in column 3. All right. So far, column 3 is address. I have no address 2, so I don't need that. My city is in column 4. So I make that 4. I've got state information in column 5. Postal code in column 6. And if I have latitude in column 8 and latitude and longitude in column 9, I can put that in there as well. 8 and 9. So, and then again, eventually, if they want to do the CPE to CM correlation, whatever column that's in will go here. So now I'm going to I've told the PathTrak server, we're going to import a list of modems, and this is going to be how the CSV file is formatted. So I'll go here, and I will choose the file. It's on my desktop. Now the key thing about this is that I'm not on the PathTrak server. This is from any remote browser that can talk to the PathTrak server. You do not have to be physically on the desktop on the PathTrak server to be able to do this. So I go here. There's my CSV file. If I open it and upload it, in a matter of moments, I'll get a response. as to whether it passed or whether it failed. And we've had this question 4 times in the last 7 days. What does this error code mean? Let me make it large. What does this error code mean? This error code means there were no errors. Error code 0, modems with error, there's nothing in there. This is the response you want when you do a modem upload. This means everything went perfectly. When you have problems, when the MAC address is bad, when your address doesn't match up, when there's some sort of an issue, you see a lot of text in this file that details what's wrong. This means all is well. So I know we've had that question at least 4 times in the last 2 weeks. So now we've got it recorded and everybody's seen it. And we actually talked about this when you guys were here in April, but everybody slept a lot since then and probably drank more. So that's this is the good answer when you do a modem upload. So now I've uploaded all of that modem information from Sweden into my PathTrak server, which trust me, makes for some really interesting geocoding around Indiana. So I'll change that later and get it back to where it needs to be. So is everybody good with the process of setting up the system, configuring it for auto import of modem and billing system data, where the file goes in the system if it's going to be automatically imported, how to add the CMTS to the system to get it going, and when you do a manual upload of a CSV file, of an individual CSV file, then this is the response that you want to get in order to be able to do that. That's where we are so far with everything. Is everybody good with that to this point?
Yep.
Eric,
Yes, sir.
Yep. Just a couple of items. It is imperative, really, that you, I mean, if you're going to set up a trial with anybody, that, as you've discovered now a few times, that you really have to have solid communication with the people that control certain aspects of their internal network, be it those that manage the CMTS or those that manage security, etc. And that really all has to be in place before you even want to start.
Absolutely true statement. I mean, we've gone from everything with battling back and forth with Liberty Global to get the access rights to some of the people in the U.S. where they've given us the case with these guys in Phoenix.
Yeah.
We've basically got the right guy that's got the right access at any point in time that we need it, and that makes things so much smoother because you don't have security people on the inside of your customer that are fighting the people that you want to sell the tool to. Sure. Because they don't think they want to give it access. So what Al says is very true. Is there's got to be some discussion within the customer so that they talk to one another and realize, hey, I have a system that is going to be needing some access to. I mean, quite frankly, billing system data is fairly secure. I mean, people want to keep that. They don't want to expose that to anybody that they don't have to. So we have to make sure that they understand that we're not exposing this to the public, and that we're using it for reference, and from a security standpoint, this server, if they set it up properly, it's not going to be hacked or breached or anything like that. So that's what Al says is exactly true. So when you're doing those trials, you make sure you're going to go in and you're going to talk to NOC managers and head-end managers, and you're going to talk to technicians, and they're going to be all fired up about this, but they're going to need some help probably at some point in time talking to a person to be able to get to this information. Another thing I want to just touch on real quick is those CSV files, people just can't resist the temptation to open a CSV file in Excel. And I can't tell you how bad that is for the CSV files that we need. Because if you have a MAC address that has only numbers and has no letters, Excel automatically converts that to scientific notation. And there's no going back. You cannot unconvert it back to a MAC address from scientific notation. So if you're going to open that CSV file in Excel, you have to import it. You have to go to the Data tab, and you have to import it from text. And you have to tell it that it's a comma delimited file and that you're using commas to do it. And that in particular, this first column is a text column. And then you can do finish and you can open it up and it will look fine. Now, if I had just double clicked it and opened it in Excel like we always do, these latitude and longitudes over here probably would have been converted to scientific notation. The zips, the postal codes would have probably been created in scientific notation, and certainly any of these MAC addresses that were only numbers would have been messed up. So you have to tell them to fight the temptation to open it in Excel, because that's another thing that we've discovered is you can tell export the file in CSV, don't open it. And people they can't help themselves. They have to open it. And then it's messed up. And they have to do it again. So if they're going to open it in Excel to look at it, make sure that when they do, they import it from the Data tab as a CSV file rather than just double clicking on it. It doesn't work well when you do that. So how have some of the things gone? What have we got going here that we've seen here of late that have worked out pretty well? We've got a few things. This came from the demo system that we got working here in the U.S. They sent us some problems that they were having, and they actually sent us the plant maps so that we could be able to make this conclusion as to where the troubleshooting was coming from. So this is one particular instance where they had again the red EQ tap is the strongest micro reflection. So this was showing up at about 670 feet, and we had a really nice grouping of our frequency response coming from the modems, and it showed up on both channels. This was a 36.8 megahertz channel. Same signature was present on 30.4. So the objective is to find the common point and go 670 feet from wherever that common point actually was. So this is what it looked like on the Pnm map. So we're able to see both frequencies. This is one frequency on the left and the other frequency on the right. So we're all in about the same part of the node where this is coming from. And when you looked at the plant map, and the plant map was huge, so this is just a small corner of it. You can see up here, Mike has highlighted in yellow some of the addresses that were showing up in PNM, and there's others down around the corner. This white line right through here, and then up through this way. If I go back one, this is this street right through here, and this area up through here is where we're looking at on the plant map. So we're looking down the street, up that one way, and back out here, and we have modems here and here, which are causing the problem, which correspond to the modems up here that we're able to see. So we have to find something that's common to all of these. And because there are modems that go on around the corner down here, with this one, and some of these that you see here, that takes this device out of the equation as being common. This device has absolutely nothing to do with this modem, or these modems. Has nothing to do with them. So it's not the common point. So based on what we see in the plant map, this amplifier is the first common device to every one of these modems. It's the first one. So we want to go 670 feet back upstream towards the CMTS from this point and start troubleshooting. So if you track this cable back upstream, there's a splice right there. And then you go across here, and right here at this 23 tap, that's 665 feet. Our PNM was telling us the problem was at about 678 feet. That's pretty close. That's a pretty close number. So that's a really, really good starting point to determine where the trouble is. If this tap's got water in it, then the signal is traveling back upstream. It's hitting this water-filled tap, and it's reflecting and going back and then hitting this and bouncing back and forth. And that's what's giving us that micro-reflection at 670 feet. So another option could be this 23 tap over here by the amplifier. Now, they were supposed to tell us what they did to fix this, but they fixed it because it's no longer there. The problem is no longer there. We suspect that this was a bad tap, and they went and replaced it. And now if you look at this node on that mid-continent system, there's no problem at all up there. They've solved it. All those modems have good frequency responses. Everything's clear and good to go. So this is a good system to explain, or a good slide to explain how you come to the common point. Is you've got modems up here that this amplifier is clearly common to, but you've also got modems that are down around the corner that this amplifier has nothing to do with. So the only device common to each of them is this amplifier right here. So that's our common point. We're going back upstream from that based on what the distance tells us to look. And we match that up with what the plant map says, and it says start at this 23 tap and see what you can find. Does that make sense to everybody? I mean, this is one of the hardest concepts to explain to the customer because they want to think 670 feet or 200 meters. They want to think that from each modem. So they want to think 600 feet from this modem. They want to think 600 feet from this modem. And that's not how it works because we have a bunch of modems that are doing the exact same thing. They're all passing through the same impairment at the same distance. So it can't be 600 feet from this modem. It can't be 600 feet from this modem. It has to be 600 feet from something common to each one of these modems. And the first device that is this amplifier. Make sense?
Yep, makes sense.
Okay, so here's a little trick that I've learned being out in the field and doing this twice. I did this in South Carolina, and we did this yesterday in Arizona. There's a way, if you have a DSAM or an ONX, that you can determine if you're at the right common point. If you go to a test point on this amplifier, and you run a DOCSIS test with your DSAM or your ONX, and you have added the MAC address, the cable modem MAC address of your meter, my file. I don't have it. I shut that down. If you've added the cable modem MAC address to the CSV file that you imported, so that it is another modem on the node, you can run a DOCSIS test. You can look at PNM, and you can see if now your meter is part of the group. So, for example, if I went to this amplifier and I ran a DOCSIS test, the modem would not join the group. It would not be part of the group that has the issue, because it would be around the corner. It's not going to be part of the problem, because the problem is up here. If you connect your meter here and run a DOCSIS test, now you have another cable modem that's passing through the same impairment that this cable modem and this cable modem are. So run the test here, no problem. Run the test here, I have a problem. This is my common point. My problem is between here and here. And I know that it's about at this distance. So you can use your meter and the cable modem that you have in your meter to join the PNM group and use it as I'm at the right spot for troubleshooting. Because we did it yesterday in Phoenix, where we were looking for a problem 1,000 feet away, and we had two possible common points. And of course, at one common point, it would show 1,000 feet, but let's go one more common point closer to the node, and oh, by the way, it shows 1,000 feet from that one as well. So that was the actual common point, not the first amplifier. So you can have that. Again, you could do that here. If you connected your meter here, it would show that there was a micro reflection 678 feet away. Oh, well, this must be the common point then. Wait, let me run a test here as well. I run a test here. It still says the problem is 678 feet away. That's not the common point. This is the common point at that point in time. So now you go to this tab, and that's where you find the problem. So it's possible to use your meter and the cable modem that it has in it to verify that you are at the right common point in the system. Does that make sense?
Yeah, really good example, that, Eric.
I tried to draw all this for Yvonne from an explanation standpoint, and it didn't work very well. So I'm glad this kind of helps out a little bit. And then again, seeing it yesterday was good as well. What time is it? So I've got another example. When you guys were here in April, you saw Jaime Pito from our partner in Latin America and Peru and Cotena, where they had the situation down there where they were able to find a couple of groups. They had two problems in two groups, and they were able to look at the map, and they actually had problems showing up in the customer's own tool with this particular node. And they got to they went to the plant maps of the area, and again they found their common point here, and 46 meters away they had a tap that looked like that. So it had an illegal hookup on it going straight into the seizure screw. Disconnect that. Problem solved again, but this was probably the key one where they looked at. They had the cable modems that were affected here, which very clearly fed back to this amplifier as a common point. Now, the distance said the fault was 80 meters away. If they look at this plant map, 80 meters is over here where there's nothing. So they opened up the pedestal where this amplifier was, and there was about 50 meters of cable coiled up in there. So once they subtracted that 50 meters, it took them straight to this DC right here. And the problem ended up being that if you look inside there, somebody had left the stinger after taking that out, so it basically had an antenna sticking out of there. So again, it's all about finding the right common point in order to be able to determine your distance to where the problem is going to be. That's the key thing. 4 cable modems right here. Every one of them comes directly back to this as a common point. Common point says 80 meters. Plant map says 80 meters is over here, but a little physical inspection tells me that I've got a little bit of additional cable all balled up inside this thing that's adding to my 80 meters. So that led them right back here from that standpoint. And yesterday in Phoenix we had we found a huge crack in a cable, and we found another piece of hard line that was somebody had either hit it with a bucket of the bucket truck, or they had dropped a wrench of some kind on it, because it was dented and scraped almost to the center conductor. And again, the key point was finding the correct common point. And that's one of the things that you could do if they had gone here and done the troubleshooting from beyond this point, then there wouldn't have been nothing would have shown common. Everything would have shown good, because from this point, then everything down this way was okay. But troubleshooting here tells them that they have the right common point. They just had to do the inspection to make sure to see why that length was what it was, why the length of the cable showed 80 meters and not just the distance to this DC. So finding the common point, key bit of troubleshooting, and you've got to have somebody that really understands the maps. And I mean, we realize also from the work that we do that being able to integrate the plant maps into the PNM map so that they're on the same picture, it would make things markedly easier. And we're working on that. We're actually using we're going to use some of the Cable One map technology that we used yesterday to see if that can layer on top of our map, and see if that might be one way that we can get this done, because that makes it a lot easier than going back and forth from one tool to the other tool. I'm looking either in this case you can see the guy here holding a big copy of the paper map, but a lot of the guys have got it on their PC and they can draw the distances to see where what the cable span actually is from pole to pole or from device to device to see how it all adds up. But if it all overlaid on the PNM system, it would make things tremendously easier. So that's what I wanted to do today in today's session. I mean, I know we could talk about this probably for a lot longer. There's a lot more stuff to cover, but I wanted to get this recorded. I wanted to get the modem. I really wanted to touch on the modem import thing, especially since that question had come up about people were getting it right and thinking that they were getting it wrong. So I wanted to make sure everybody was clear on that. I wanted to make sure everybody understood how to configure the XML file for the auto import and where to put the file, and then basically how to set the system up for PNM, how to get the CMTS up and going, and then go from there, and how to do a little troubleshooting once you start getting information. So does anybody have any questions about what we've covered today? I mean, is this a good thing, guys, in Europe particularly? I mean, if we keep doing this more and more and get into the, I mean, there's the cross-reference between the port name and the fiber node name that we can touch on. There's a lot more that we can touch on as far as this system, getting this system to work, but I wanted to start here and get you guys at least some familiarity with PNM, and that way when you get questions about it, you'll be a little bit more, you'll have a little bit more info about it.
Eric, a quick one regarding DSAM. You mentioned we could use it or Linux to find the command point.
Yes.
Or to use PNM data. We need to have also DSAM having the possibility to forward all the information, the PNM, the SNMP stuff. So it could be a different configuration with a config file of the DSAM as one of the modem.
It could, but I doubt it. I mean,
yeah,
I just don't think.
So it didn't work at LGI. So
it didn't. Well, LGI's they do have different configs, and that's a good. Yvonne, that's an excellent point. That is another thing that I wanted to touch on. For some reason, some customers like to change their community strings for the cable modems. LGI is one of them. LGI is one that likes to change, and we actually put it in the system under configure, system settings. This is where this is. Modem. If the customer is one of the people that likes to change the read and write community strings for their cable modems, you can change it from within the PathTrak system now, and it actually will write it to the database. Because when we first released PNM, we assumed that everybody would leave the cable modem community strings alone, and they would just be maybe public and private or something like that. Because it's the cable modem. The act of going through and changing the community string in the cable modems is hugely time consuming, and I'm not sure what value it adds, but Liberty Global thinks it adds something, so they do it. But they're the only ones so far that we have seen that do it with the modems. Everybody else just leaves it at the default.
Yeah, I see a couple of other customers in Europe doing that.
So if you have somebody, if you have a customer that is changing their SNMP community strings for their modems, and we're going to need to put that information in the database so we can communicate with it, then this is where you can go in and change that. And in some cases, I think some people have actually talked about doing it for their different tiers of service. If they have the gold, silver, and bronze tier of service, they have a different community string for each tier. We can't do anything with that right now because we can only have one read-only community string to get PNM. So if they're using different community strings for different classes of modems, we're going to have problems with that from a PNM standpoint, at least right now. And again, that's a very rare, very, very rare circumstance. But the act of actually changing it, LGI did it, and Yvonne, you say you've seen a couple other people in Europe that have done it. So this is how you can change it so that it changes the database and updates the community string, and then it should be able to talk to the modems. Good. Thanks for bringing it back up, Yvonne. That was I wanted to remember that and didn't. All right, guys. Any more questions?
No.
I will put this recording on a YouTube channel. I'll put it out there, and anybody that couldn't make the call, I know Stefan from Norman wanted to be on the call and he couldn't make it, and I know that one of the guys, Andy I know Andy was out on having a day off, so he couldn't make it. He wanted to see the recording as well, so we'll make sure we get it to him. And then that way we've got some reference material as well. And that'll be the idea with these is we go through them, record them, and hopefully answer any questions that you guys have, and it'll get you some familiarity with some of the new things that are going on. And then you've got reference material that you can go back and pull information from and go from there. So if there's no more questions, we'll call this done. Thanks for sticking around for the additional time, and thanks for accommodating all and every one of the time changes that I had in there.
Very useful today. Thank you, Eric.
Thank you, Eric. It was great. Thank you.
All right, guys.
Bye.
Everybody have a great weekend.
Bye, everybody.
You too, man. Thank you. Bye.
Bye.